Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So as you all know, we have started a series and we have come a long way where we are completing the whole syllabus for chemistry and we are practicing a lot of questions and solving previous year questions, right? So today we will be discussing the aldehydes, ketones and carboxylic acid part 2, where we will be covering the physical properties and the chemical reactions, okay? So this is a major topic from where a lot of questions have been asked. So yes, now one more request, please join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section of this video, so you can go there and join the WhatsApp channel, okay? So now without further delay, let's get started. I want all of you to sit with a notebook and pen so that you can note down all the reactions and you can make a flow chart of different reactions so that you can revise it easily, okay? So now let's get started. So as I tell like how we are going to cover this chapter, so this is very important so that you should know that in how many parts we have completed the chapter, what are the different topics, so that while revising, while recalling, you can have this flow chart in your mind and then you can revise, okay? So the first one, part 1, part 2, 3 and 4. So in the first part we are going to cover the nomenclature, structure and the preparation of aldehydes and ketones, okay? So this we have already done in the previous lecture. Now in today's lecture, part 2 will be doing physical properties and the chemical reactions of aldehydes and ketones. Now in the next part, part 3 will be starting carboxylic acid, where we will be doing nomenclature, structure and the methods of preparation. And in the last part for carboxylic acid, we will be discussing its physical properties and its chemical reactions, okay? So today we will start with physical properties and the chemical reactions. This is very important topic, very important topic, okay? Fine. So now coming to the weightage wise, so you can easily see a very high weightage topic, 3, 4. So I can say 3 to 4 questions you can expect from this particular chapter. And in organic chemistry, it is not like the questions will be solely from this aldehydes, ketones and carboxylic acid chapter. It can vary because you know some reactions will be taken from haloalkanes chapter, some reactions will be there from alcohols. So to solve one question, you need to master all the 4 organic chapters, okay? Amines can be like a different one, but these 3 first, haloalkanes, alcohols and phenols and aldehydes, ketones and carboxylic acid, the reactions are intermixed, okay? So please prepare all these 3 chapters very well, okay? Now coming to today's part 2, that is aldehydes and ketones. As I told you, we will be talking about physical properties and the chemical reactions. So under physical properties, we will be talking about boiling point and solubility, and in chemical properties, we will be talking about nucleophilic addition reaction, reduction reactions, oxidation reaction, reactions due to alpha H and other reactions, okay? So 5 categories we have, okay? So clear. Physical properties, will talk about solubility and boiling point, and in chemical reactions we will be talking about nucleophilic reactions, oxidation, reduction, reactions due to alpha hydrogen, and the last one, other reactions, okay? So now talking about physical properties, so the first one is about boiling point. So boiling point, if you see the order, alcohols have the highest boiling point, then aldehydes and ketones, and then ethers, okay? Now the reason here for alcohols having very high boiling point, we know it is intermolecular hydrogen bonding. Now aldehydes and ketones are also polar molecules, okay? So they have some intermolecular forces within them, so that is why the boiling point of aldehydes and ketones come more than your ethers, okay? This order you can remember. Now coming to solubility, so solubility is like the lower mass compounds like your methanol, ethanol, propanol, okay? These are miscible with water in all proportions because they can form hydrogen bond with water. But as the chain increases, okay, I can say the carbon chain increases, the solubility in water decreases, okay? So the solubility of aldehydes and ketones decreases rapidly on increasing the length of the alkyl chain, okay? But these compounds, aldehydes and ketones, are very easily soluble in organic solvents like benzene, ether, methanol, chloroform, etc. Okay, so this is all about the physical properties. So what you can take from here, the lower aldehydes and ketones are very easily soluble, but as the number of carbons increases, the solubility decreases in the in your water, right? Okay, next coming to the chemical reactions of aldehydes and ketones. So here, as I told you, there are 5 reactions. First one is nucleophilic addition, second one reduction, then we have oxidation, next reactions due to alpha hydrogen, and the next one is other reactions. Now under nucleophilic reactions we have further addition of HCN, addition of NaHSO3, addition of Grignard reagent, addition of alcohols, and addition of ammonia and its derivatives. So under nucleophilic addition we have 5 reactions: addition of HCN, addition of NaHSO3, addition of Grignard reagent, addition of alcohols, and addition of ammonia and its derivatives. Okay. Now coming to reduction, here again we have 2 types of reductions: reductions to alcohols and reductions to hydrocarbons. Okay. These flowcharts are very important to remember and to revise the reactions. Okay. So if you are watching this video, please make this flowcharts. Okay. This hierarchy charts, you must make it. Okay. Next, coming to under oxidation, so we have Tollens test, we have Felling's test, and we have oxidation of methyl ketones. Next, coming to reactions due to alpha hydrogen, so here we have aldol condensation and cross aldol condensation. Then under other reactions we have Cannizzaro reactions and electrophilic substitution reactions. Okay. Very simple one. Let us revise once again all the list of reactions. So for chemical reactions we have 5 types of reactions. First is nucleophilic addition reaction. Under nucleophilic addition reaction we have 5 types of reaction: addition of HCN, addition of Grignard reagent, addition of alcohols, addition of NaHSO3, and then we have addition of ammonia and its derivatives. Okay. Second reaction is reduction. Under reduction again we have 2 types: reduction to alcohols and reduction to hydrocarbons. Okay. Then third one is oxidation. Here we have Tollens reagent, Felling's reagent, and oxidation of methyl ketones. Next, the fourth type of reaction we have is reactions due to alpha hydrogen. Here we have aldol condensation and cross aldol condensation. Then coming to the next one, that is reactions, other reactions. Under that we have Cannizzaro reaction and electrophilic substitution reaction. Okay. So now let's get started with the first part, that is nucleophilic addition reaction. Okay. So as I told you, 4 types of addition we have: addition of HCN, addition of NaHSO3, addition of Grignard reagent, addition of alcohols, and addition of ammonia and its derivative. So here let me just explain you the mechanism of nucleophilic addition. Mechanism of nucleophilic addition reaction. Okay, very simple one. So this mechanism you can understand very easily if you remember the structure of carbonyl compounds. So we had like this. This is any carbonyl compound, and we have discussed that oxygen is electronegative. So here there will be a delta positive charge, and here there will be a negative charge, and here there will be delta positive charge. Now nucleophile, as you know, is something which is electron rich species, right? So nucleophile can attack on this carbon, and this bond shifts here, right? So what I'll get here, we will get nucleophile and O minus. Okay. So this is what is the mechanism. Here we will be adding these different nucleophiles to this particular carbonyl compound. Okay. So now let us start with the first one, that is addition of, so first one is your addition of HCN, right? So that is the first one, addition of HCN. So here if you remember, this is H plus and Cn minus. So which is the nucleophile? Cn minus is the nucleophile. So Cn minus will attack on this carbon and bond will shift here and will get O minus, and this O minus will abstract this H plus to get this compound. Okay, and this compound name is cyanohydrine. Okay, first one. Now coming to the second addition, that is NaHSO3. Okay, so if you see now, this is Na plus and this is HSO3 minus. So this one attacks on this carbon, this bond shifts here, so we get O minus Na plus, and O from here we get O SO2H. After that there is a proton transfer from here to here, so H goes here and Na comes here, and we get this compound OH and OSO2 Na. Okay, so this is your second one, that is addition of NaHSO3. Okay, now coming to the third one, that is addition of Grignard reagent. So if you remember Grignard reagent, Mg plus R minus, so this one goes here. Okay, so R attaches here and we get OMgX, then with hydrolysis that gets converted to OH, right? So this is your third one, that is addition of Grignard reagent. Okay, next fourth one is addition of alcohols, right? The fourth one is addition of alcohols. Okay, so now this is very important here to understand how this process takes place. Now see, now this alcohol, oxygen has lone pair. Okay, so that is why this oxygen behaves as a nucleophilic agent, or it is a nucleophile. So what will happen first of all, so this one will break as, like you can say, RO minus and H plus. So this RO minus will attack on this carbon and bond will come here, and O minus will take this H. Now this compound is called as your hemiacetal. This is very important. This compound is hemiacetal. Now again what happens here, O, this one will give you R dash O minus and H plus, right? So this oxygen takes this H plus and it becomes O plus H2. After that this one again attacks and this bond shifts here to get you OR dash and OR dash, and this is called as acetal. Okay, so this reaction doesn't stop here, it converts to this one to get you acetal. Okay, so when you have carbon with one OH and OR dash group, that is called as hemiacetal group, and when you have this OH again reacts with another alcohol molecule and gets converted to OR dash, we call it acetal molecule. Okay, so this is your fourth one, that is addition of alcohols. Next, coming to fifth one, addition of ammonia and its derivative. This is the fifth one, addition of ammonia and derivatives. Now, so now here the addition of ammonia and its derivatives, this is very, very important from exam point of view. Okay, you get a lot of questions from here. So now, but it is very easy. What you have to do, see the mechanism. If I tell you, you have like this C double bond O and you have here H2N and this is Z. So if this Z is H, then it is ammonia. If it is something else, then it is called as ammonia derivatives. So when you add this one, what will happen? This water will go, okay, and we will get double bond N and Z. Okay. So that is the product that you should remember for the reactions of ammonia and its derivatives. Okay, so now I'll show you the different ammonia's derivatives also, and the names you must remember. Okay, so now we are done. So as we talk about nucleophilic addition reaction, so we discuss about 5 addition reactions. First is your addition of HCN. This will give you cyanohydrin. Second is addition of NaHSO3. Third is the addition of Grignard reagent. Fourth is the addition of alcohols. Here we get hemiacetal and then it gets converted to acetal. And the fifth one is the addition of ammonia and its derivatives. Okay, so now coming to check the ammonia and its derivatives, this is very, very important. So now if you see, I told you we need to write like this, right? We have C double bond O plus H2N and then I have Z. Now these Z's are different things given here. Okay, so if this Z is H, then no doubt it is ammonia and we will get C double bond NZ and H. So the product, if you remember, the product was like this, double bond, here water will go and we will get NZ, right? So if H is there, then this Z is H. Next you have R, so here this is R. But here you should remember the names. Okay, this is called addition and the product is called as imine. Okay, here if you NR, this is called as substituted imine. Okay, next if you have here like this, that is H2NOH, right? Then this is called as hydroxylamine and the product is called as oxime. The name of the products, this is double bond N, so this is your Z, so Z has come here, right? This is again oxime. Next if you see hydrazine, so this is like hydrazine is NH2 NH2. Right, so here this is your Z, so this is your Z and this is called as hydrazone. The compound is called as hydrazine. After it reacts with carbonyl compound, we get hydrazone. Okay, next coming to, this is phenylhydrazine. So just you replace one hydrogen with phenyl group, phenylhydrazine, and we'll get the product phenylhydrazone. Then you have in this phenyl group you add NO2 groups, so 2,4-dinitrophenylhydrazine, and the product will be 2,4-dinitrophenylhydrazone. Okay, next, this is important, semicarbazide. Okay, so CONH2 if it is there. So this group attached here, semicarbazide, and the product is called as semicarbazole. So these all reactions are very, very important. So you can remember how many we have, 1, 2, 3, 4, 5, 6, 7. So 7 reactions we have under ammonia and its derivatives. Clear? So these reactions are very, very important. So please prepare them, but very simple, you just need to write it correctly. Okay, so whenever you are writing, make sure that NH2 and Z, you remember this format, NH2Z format should be there. So Z can be attached, H2 will go, and NZ will be the product. So whatever is the Z, just keep it there as it is. Clear? Okay, now we'll go to the next topic, that is reduction. So I told you under reduction we have two types of reactions, reduction to alcohols and reductions to hydrocarbons. So under reductions to hydrocarbons we have two name reactions. Okay, this is very important, Wolff-Kishner reaction and Clemmensen reduction. Both of them are important name reactions. Okay, important name reactions. So we need to see what are these reactions. Okay, and another is reductions of carbonyl compounds to alcohols. These reactions we have already studied in the alcohols chapter. Okay, now when we discuss it will be more clear to you. So this is first one, that is reductions to alcohols. Reductions to alcohols, right? So what are the reagents we can use? We can use LiLH4, NaBH4, and one more is here, that is hydrogen palladium. Right? These three reagents will convert this group to CH2OH group. Right? Okay. Next, coming to reductions to hydrocarbons. So if you use ZnHg and HCl, okay, this O part will go and there is 2 hydrogen is added. So as you can say, this is removal of oxygen and addition of hydrogen, and that is what is the definition of reduction reaction. So now these are reduced to hydrocarbons, and this particular reaction is called as Clemmensen reduction. Clemmensen reductions. Okay, so this is your second reaction. Second, that is reductions to hydrocarbons. First one, Clemmensen reduction. Now you can remember another one here, NH, the same thing. So you can remember what is the speciality here. This reaction is done in acidic medium. Okay, the same thing we can also do in basic medium with the reagent NH2NH2. What is this NH2NH2? If you have just we have seen, this is called hydrazine. Right, and this product we get is hydrazone. Right, so this happens simple, addition of this ammonia and its derivative. So H2 and O is removed to get N and NH2. After that, if you treat it with basic medium, KOH and ethylene glycol, and heat it, we get this CH2. This part gets converted to CH2 and a byproduct of N2. Now this reaction is called as Wolff-Kishner reduction. Okay, Wolff-Kishner reduction. Now how to remember this one? So I'll tell you a very easy trick to remember this. So you see, in Wolff there is double F, 2 F's are repeated, and you see here NH2 is repeated. Okay, so that's how you can think that, okay, Wolff-Kishner will have something which is repeated. So NH2 will be there, and with NH2 there is basic medium, with zinc it is acidic medium. Okay, so Clemmensen is acidic medium, Wolff-Kishner is in basic medium. Okay, so here you can see this is basic medium. Right, so we have seen now reduction reactions. Under reductions there are 2 reductions. One is reductions to alcohols, and for that what reagent we can use? NaBH4 and LiLH4 or hydrogen palladium. Next we have reductions to hydrocarbons. For that again we have 2 reactions. One is your Clemmensen reduction. Reagent required is ZnHgHCl, and for Wolff-Kishner the reduction reaction, the reagent required is NH2NH2KOH in presence of ethylene glycol. So this is in acidic medium, this is in basic medium. Clear? Okay, now we'll go to the third reactions, that is oxidation reactions. Okay, so under oxidation reaction As you have seen, we have three reactions now: tolerance test, Felling's test, and oxidation of methyl ketones. Okay, so this all things we will discuss. Apart from that, there are something that I want to talk about: oxidation. So see, if you have RCOH, okay, this is a one aldehyde. So aldehyde on oxidation will give you carboxylic acids. Okay, carboxylic acids are produced by the oxidations of aldehydes. Now if you have ketone group, okay, if it is a ketone group and you do oxidation, then there can be different products formed here. Okay, so now what happens here, we can get this can break like this. Okay, this can break like this to give you R dash OH plus R dash, I'll make it R1 and R2 for more clarity. Okay, so we can get here, okay, so here we can get R1 OH plus R2 COH, this is possible, plus this bond can break here to give you R2 OH plus R1 COOH. Okay, so when ketones undergo oxidation, there are different types of products are formed. Clear? So now talking about the oxidation of ketones. Okay, so if you see, if I draw like this, R CH2 C double bond O CH2 R dash, okay, and I do oxidation. Okay, so just let me number the carbons here: carbon 1, carbon 2 and carbon 3. So we can get a mixture of products here. So how we will get? See, there can be a cleavage of carbon 1 and 2. So if there is a cleavage of carbon 1 and 2, so what I'll get here, this part will get converted to one acid, so RCOOH, okay, plus I'll have this side converted to one acid, that is R dash CH2 COOH. Okay, that is one possibility. Clear? I hope you can see this. Now there is a possibility that this bond is breaking. Okay, this bond is breaking. Now if this bond is breaking here, then this part will get converted to an acid, so I'll get R dash COOH, R dash COOH plus RCH2 COOH. Clear? So this, you can see a mixture of acids we can get if ketones are oxidized. Okay, so now we'll see some reactions of oxidations of aldehydes. So tolerance test, Felling's test and oxidations of methyl ketone. Okay, so first coming to the tolerance test. So aldehydes reacts with this reagent, silver ammonia, ammonium silverate, you can say. This is called as your tolerance reagent. Okay, so now this reacts with this one. So here a small error in the spelling, 1 second. Okay, so tolerance reagent. So now if you react with this one, this aldehydes will get oxidized. These are mild oxidizing agent, so it will get converted to your acid, but we'll get salt of acid, RCOO minus. Then this silver gets reduced. Okay, so if this one is getting oxidized, silver will get reduced to give you Ag plus NH3 plus water. Okay, you need to remember just this one. Okay, RCOO minus is formed. This is your tolerance reagent or tolerance test, first one. Okay, next you have second one, that is your Felling's test. Okay, Felling's test. Second one here, Felling's test. Here copper 2 plus is taken, again in OH minus medium, or you can say in basic medium. So you will get copper oxide. This copper oxide is a red precipitate. Okay, and you will get RCO minus and H2O. Here what will be the observation? We will get a silver mirror on the glass tube. silver mirror formation is there. Okay, so these are tests for aldehydes, right? So that means what, when you put it, you will not be knowing like this is an aldehyde or not. So some observation should be there to know, okay, this is an aldehyde. So what you have to take the given compound to you and then add tolerance test. If you can find in the test tube some silver lining is formed, okay, silver lining is formed on the test tube, then you can easily confer that, okay, this is a aldehyde. Okay, similarly, if you take this one aldehyde and add the Felling's reagent, okay, then you will find immediately a red precipitate. Now this red precipitate is due to the formation of copper oxide. Now this indicates that, okay, this compound which was taken for the testing is a aldehyde, okay, is an aldehyde compound. Okay, one more Felling's test, you should remember Felling's test has two solutions, okay, it consists of Felling A and Felling B. Felling A is your copper sulfate solution, okay, and Felling B is sodium potassium tartarate. Just remember the names, it can be asked anytime. So Felling solution is a mixture of sodium Felling A solution and Felling B solution. Felling A is copper sulfate and Felling B is sodium potassium tartarate. Okay, so next coming to another feature of Felling's test. Okay, so Felling's test cannot oxidize aromatic aldehydes. Okay, so I'll write here aromatic aldehydes do not give Felling's test. Okay, I'm writing it in short. I hope all of you can understand this one. Okay, this is very important. Aromatic aldehydes means your benzaldehyde. Okay, benzaldehyde will not show Felling's test. Okay, clear this one. So under oxidation, tolerance reagent, what is the reagent for tolerance test? AgNH3 plus this one will give you salt plus Ag plus ammonia plus water. Copper 2 plus, if you react for Felling's test, you will get again acid, copper oxide and water. Here in Felling's test, you should remember it is not applicable or it doesn't show positive test with aromatic aldehydes. Okay. Now third one we had oxidation of the third one. So this is second one, this is third one, that is oxidation of methyl ketones. Oxidation of methyl ketones. Third one. Now any group, any aldehyde, any ketone which has this group, which is this group, COCH3 group, if this group is present, then this reaction will happen. And in this what happens, you take NaOX. Okay, so after this what happens, this group converts to acid. Okay, here there is a break, the compound breaks here and we get CHX3 and this part gets converted, gets oxidized to give you RCOO minus Na plus. Okay, so here there is a breaking, this bond breaks, this gives you CHX3 and this part converts to acid to give you sodium salt of carboxylic acid. Now here generally we take X is equal to I. If X is equal to I means that is iodine, then this reaction is called as iodoform reaction. Okay, iodoform reaction means we will get here CHI3 and this CHI3 is called iodoform, which is yellow in color. Which one? If you take iodine, CHI3. Clear? I hope all the reactions are clear to you. For oxidation, we have tolerance test, we have Felling's test, and then we have oxidation of methyl ketones. Clear? Okay, now let us go to the next reaction, that is reactions due to alpha hydrogen. This is very, very important, very, I'll say, I don't know how many stars I can put here, very, very, very important reactions, aldol condensation. Now what is this alpha hydrogen? First let us understand that. When you have a aldehyde or a ketone group, like for example CH3COH, okay, so if this is there, then I'll write it in this way. One second. Okay, suppose this is the structure. Now this is the alpha carbon, the hydrogen attached here is called as alpha hydrogen. Okay, so those compounds which contains the alpha hydrogen can show this aldol reaction. Okay, so first condition for aldol condensation is what? It should have alpha hydrogen. Okay, next what is the reagent required here? Reagent required here is dilute NaOH. Okay, now we'll see one reaction, one example of aldol condensation. So just simple reaction you take, for example CH3COH. Okay, now in this presence of dilute NaOH, what will happen? This is a base, okay, it will abstract this alpha hydrogen. Base abstracts the alpha hydrogen. So what I'll get here? CH2 minus COH. Okay, now this one, this aldehyde, we can take another molecule of this aldehyde. So I'll get CH3COH. Now what happens? This one will attack on this one and this one will form here, right? So what product I'll get? I'll get here CH2. You just write this one. We have CH3, C double bond OH, right? Now, okay, this one attacks here, this bond goes here, so I'll write it as O minus. Okay, so this one is O minus. Now this CH2 group has attacked here, so we will get CH2 here, okay, and then we have COH. Okay, now what happens? This oxygen will take H plus and gets converted to OH. Now if you heat this one, okay, if you heat this compound, so what will happen? There will be dehydration. Okay, now dehydration, what is there in dehydration? So just I'll write it in this way. See, we had here OH and H. Okay, so this is your OH and here H is there. So now what will happen? There will be dehydration from here and I'll get the compound as CH3C, then here CH, here I have double bond, then here again CH, and then we have here COH. Okay, so now you see this part is called aldol reaction, and then when you heat it, there is a removal of water molecule and we get aldol condensed product. Now this carbon is alpha, this carbon is beta. So this compound is called as alpha beta unsaturated compound. Alpha beta unsaturated compound. Okay, so this is the complete mechanism of aldol condensation. Now a question may arise, ma'am, do we have to do this mechanism every time? Because this is a very important question, very important topic. So aldol condensation questions are definitely going to be asked. So there is a trick to draw the products. Very fast you can find out the product. So I'll tell you that trick now. Okay, so time for now trick. See, first of all, whatever is the reactants, you have to write it vertically, one below another. So our reactant is what? CH3COH. So I'll write like this, CH3C. So I'll write the, we'll write it little up so that we can see it. Okay, so this is the trick. Okay, now let me write CH3COH. Another molecule of CH3COH, so write it below. Okay, now what you have to do is, you have to take this alpha carbon, right? The alpha carbon of one carbonyl compound should be connected to the carbonyl compound. So just connect it here. Okay, after that remove one H from here, so this will become H2, and add that H here, this will become OH, and this bond will go. So now if I write the product, CH3, start from the chain, okay, CH3, then we have C, here I have OH, okay, OH and H. Next this carbon is connected to this CH2, okay, and then we have C double bond OH. After that, you know, here OH and H will be there, so there will be dehydration. So just remove this one and add a double bond here. Okay, so by simply this, using this vertical system, you can easily find the product within a minute. Okay, you need not do this whole mechanism. Clear? Alpha aldol condensation clear to everyone? Okay, so this is very, very important. Please understand the mechanism once again. First, dilute NaOH will abstract the alpha hydrogen, right? Alpha hydrogen is abstracted. Now this will give you a nucleophile. Now this one attacks on this carbonyl carbon, then another molecule of the same compound, and then we get a product, and then there is dehydration and we get alpha beta unsaturated compounds. And here is the trick. You have to write both the products vertically, connect the alpha carbon of 1 to the carbonyl carbon, remove one H from here, add one H here, and then just you can write down the product and remove the hydrogen OH and H to give you alkene. A question may arise, ma'am, why this H was not removed? So you have to remember, more substituted alkenes will be formed as a major product. Okay, fine. Next, coming to cross aldol condensation. So in cross aldol condensation, what happens? You have to take two different two different aldehydes. Okay, so the mechanism is very same. So first of all, we can have CH3CO CH3, sorry, not two different aldehydes, two different carbonyl compounds which contains alpha hydrogen. So this is one reactant and I have another CH3COH. Okay. So this is the two reactants that we have taken to give you cross aldol condensation. Now suppose I mark as this is as A and this is as B. So we will get 4 products during the cross aldol condensation. What are these 4 products? You will get a product when A plus A is reacting, when B plus B is reacting. Next you will get when A plus B is reacting, and then you will get when B plus A is reacting. Okay. So now we will react all of them. I will do the products quickly with the trick that I told you. So first one, if you see, A plus A means this one plus this one. So I'll write CH3 CO CH3, below that again CH3 CO CH3. Next, what I told you, you need to connect that alpha carbon to this one, right? Remove one H from here and make this one as OH. So what I'll get, product, final product, start writing the products from here. I have CH3, okay, then we have C, here we have OH, okay. Now this carbon is connected to this one, right? So here it is CH2 now. Now to this carbon another CH3 is there. So that CH3 you should not forget. Then again C double bond O, and then we will get CH3. Now there is one H here, right, this H, so there will be dehydration. So I'll get a double bond here. Okay, so yeah, sorry, this is the product for A plus A. Okay, now we will do B plus B. So B plus B already we have done, right? CH3COH. So what we got here, 1 2 3 4. B plus B product we have already discussed. We got, this was the product for B plus B, right? Okay, we got, this is for B plus B. Now I'll tell you how to do A plus B and B plus A. So A plus B means I'll write like this, CH3 CO CH3 plus B, that is CH3 COH. Then what is the trick here? Trick is just connect this alpha carbon here, remove one hydrogen here and make it OH, right? So I'll just write down the product now. So product will be, see, this is CH3 here, okay, here it is CHOH and here it is CH3, okay, then we have CH2 here and we have C double bond OH. Now there will be a dehydration here, we'll get double bond here, and this one will be, this one we have to remove, right? Yeah, so we'll get a compound like this for A plus B. Okay, similarly you have to react B plus A. Okay, so for B plus A, so this is your A plus B product. Next I'll write B plus A. So B plus A, let us do this one here, that is CH3 COH plus CH3 CO CH3. Here this one will connect. Okay, so what I'll get, CH3, here I'll get CO, so there will be a double bond between these two carbons. By now we have practiced that. Then we'll get CO and CH3. Okay, so this is my product for B plus B, sorry, B plus A. Okay, so now let us write all the 4 products together. Okay, so for A plus A, okay, for A plus A, the product we got is this one. So I'll write it like this. I need a little space here. So we'll rub all the mechanisms and only products we can keep. Okay. Okay, so I have this one, all the 4 products, so that you can understand what are the different products that is formed. Okay, so this is your first product, that is A plus A. Okay, we got a ketone for A plus A. Next, this is for B plus B. We got one aldehyde. Now if you see, this one is A plus B, here we got aldehyde, and here we got again a ketone where is B plus A. Okay, so you can say we can get 4 products when you do cross aldol reactions. Okay, so these all 4 products you should be able to do it quickly by using this trick. Clear? Okay, so now we will go to the next, the 5th type of reactions, that is Cannizzaro reaction. So Cannizzaro reaction is very easy. You just need to remember one condition for Cannizzaro, that it should not have no alpha hydrogen should be there. And next thing, it is a disproportionation reaction. Okay, and I hope all of you know what is a disproportionation reaction. Disproportionation reaction means the same molecule undergoing oxidation and reduction. So if you have any aldehydes or ketones, so aldehydes on reduction will give you alcohols, and on oxidation will give you carboxylic acid or the salts of carboxylic acid. And what is the reagent required here? Concentrated NaOH. So remember, for aldol condensation we require dilute NaOH, but for Cannizzaro we require concentrated NaOH. Now let me take one example here. So if I have this one, HCOH, right? So this is not alpha hydrogen. Alpha hydrogen is the hydrogen attached to the carbon next to the carbonyl group. So there is only one carbon, so this compound has no alpha hydrogen, so this can show Cannizzaro reaction, right? No alpha hydrogen. So what will happen here? There will be concentrated NaOH. Okay, so this one will undergo oxidation and this one will undergo reduction. So if undergoes reduction, so what I'll get? Alcohols I'll get. So first CH2OH, and I'll get a carboxylic acid. So I'll get HC double bond O minus Na plus, salt of carboxylic acid. One more example if I take here, you can take benzaldehyde, right? So this is the alpha carbon, but here if you see, this carbon has no hydrogen, so this also has no alpha hydrogen, so it can show Cannizzaro reaction. So if I take, what is the reagent required? Concentrated NaOH, right? So if this one is there, then what will be the product we'll get? Again this one is there. First of all, this one will get converted to alcohol, right? And next one, this one will get converted to salt of carboxylic acid. Okay, so self oxidation and reduction. So alcohol is your reduction and the salt is your oxidation product. Clear? So done with this also. So now the next one is electrophilic substitution reaction. So here you have to remember that either it is either aldehyde groups or ketone groups. Okay, so these are electron withdrawing groups. If electron withdrawing groups means they will be meta directing groups. Till now whatever we are studying, like we have studied reactions of alcohols and phenols, ethers, right, like aromatic ethers. So these were your electron donating groups and they were ortho-para directing. But you have to remember, for benzaldehyde and for if you make acetophenone, these are your electron withdrawing groups and meta directing groups. Okay, so we'll see one simple reaction. The first one, nitration. Okay, so under nitration, suppose we have this one, benzaldehyde. Okay, and for nitration, I hope all of you have remembered the reagent. What is the reagent for nitration? Concentrated HNO3 with concentrated H2SO4, right? So what will happen? What we have to remember is that the nitration or the nitro group will be attached at the meta position, right? So this one will be attached at the meta position, NO2 group. Okay, so we'll get only one product. Clear? So now we are done with all the reactions. So now it's time to make a revision of the reactions that we have studied quickly. Okay, in the main sheet here, we'll revise all the reactions. Okay, so I'll erase all the ink. First one, addition of HCN. What was the product? Cyanohydrin. Next, addition of NaHSO3. First ONA and HSO3 will be added, and then there will be proton transfer. Addition of Grignard reagent. Addition of alcohols, this is important, acetals and hemiacetals will form here, right? Next, addition of ammonia and its derivatives. So how many ammonia and derivatives were there? 7 were there. Clear? Now coming to reductions to alcohols, what is the reagent required here? Here we required NaBH4 or LiAlH4 or hydrogen palladium, right? Reductions to hydrocarbons, here we have two reactions. One is your Wolff-Kishner, and the another reaction that we have studied was Clemmensen reduction, right? Clemmensen reduction. So Wolff-Kishner, I told you in spelling 2F comes, so there should be two repeated structure, that is NH2NH2, and here it KOH, basic medium, and here in the Clemmensen reduction, what is there? ZnHg and HCl, acidic medium. Okay, now coming to oxidation for Tollens reagent, the reagent was AgNH3 whole 2 plus, right? And this gave you salt, silver mirror test, and it is given by aldehydes. Felling's test is your copper 2 plus. Okay, here you should remember that aromatic aldehydes do not give Felling's test. Next, oxidation of methyl ketones, we have NaOI. Okay, iodoform reaction, yellow precipitate. Next, coming to aldol condensation and cross aldol condensation, reagent is dilute NaOH. You must remember the trick that we have studied. Cross aldol condensation will get 4 products generally. Okay, if one of them is there which is not having alpha hydrogen, then we will get 2 products. Okay. Next, Cannizzaro reaction, the reagent used is concentrated HNO3, will get self-oxidized and self-reduced products. Electrophilic substitution, you should know it is meta-directing groups. Okay. So, I hope a brief revision we have done of all the reactions. So, now it's time to practice the questions. Okay. Okay, now it's time to practice the questions. So this is a homework question that I gave you in my last class. Let me see how many of you have answered it correctly. 1 mole of a symmetrical alkane on ozonolysis gives 2 moles of an aldehyde having a molecular formula of 44U. So when it is telling symmetrical alkenes, you can know that 1-butene and propene is not symmetrical alkenes. Now if you see ethene is a symmetrical alkene, but the aldehyde will get from ethene will not have a molecular mass of 44 because there is only 1 carbon. So definitely it has to be butene. So if you remember, butene structure is like this: CH3, CH, double bond, CH, CH3. So here what will happen? There will be a breaking of the bond and we will get CH3CHO. 2 molecules of this one. Now if you see the mass here, we have carbon-carbon 12 2s are 24, then we have 1 oxygen that is 16, and we have 4 hydrogens, right? So I'll have here mass 6 plus 4 10 14 44 gram. So the correct answer for this question will be but2-EMe. Okay, fine. Now let us move to today's question. So these all are your PYQs. Okay, all these questions are your PYQs. Compounds A and C in the following reaction is. So first there is CH3CHO and CH3MgBr. So under nucleophilic addition reaction, we have studied about the addition of Grignard reagent, right? So we can easily find this one, CH3COH, and here there is addition of CH3MgBr. So now I told you, whenever you do Grignard reagent, just do plus minus, minus plus, then add minus to plus, plus to minus, and OMG bar will get converted to OH. So what I'll get here, CH3C, here it will be OH, okay, and here it will be CH3. So this is propane 2OL I'll get. Next you have concentrated H2SO4 and heating. So H2SO4 and heating will do dehydration, right? So what will happen? There will be removal of this double bond and I'll get CH3CH double bond CH2. That is your, so this is A, this is B. Okay. Then after that there is hydroboration oxidation. So hydroboration oxidation, if you remember, it adds H and OH following anti-Markovnikov's rule, right? That also we have studied in the previous class. So I'll get CH3, CH2, CH2OH. Okay, so this is your C. Now if you see, question is asking A and C, which is A, this is A and this is C. Here OH is in the second position, here OH is in the first position. So these two are what? These two are positional isomers. So the correct answer for this question will be option number B. Okay. Next, coming to question number 2, CH3CHO plus HCHO in presence of dilute NaOH heat. So if you remember this one, dilute NaOH, you can remember just now we studied it is which reaction? Aldol reaction, right? So first let us write the product for this one. So now see, this is what important one, HCHO, and then we have CH3COH. Now this carbon doesn't have any alpha hydrogen, right? So it cannot attack. The alpha hydrogen is present in this carbon, so this one will attack on this carbon. Okay, so I'll get, first of all, what is the trick? Let us follow. We'll join these two. We'll remove one H from here and we'll add one OH here, right? So what will be the product first I'll get? We'll start from this one. Here it is CH2OH, okay? Then we have CH2 and then we have COH, right? So now there is heat, so there will be a removal of water and we'll get a double bond here. So this one will be an alkene produced here. Now there is addition of HCN. So if you remember HCN, what does it do? Nucleophilic addition again, right? OH and CN will form, cyanohydrin will get. So CH2CHC, I'll get OH and then CN. After that there is hydrolysis. So hydrolysis will convert this CN to COOH. So what I'll get after that? COOH. Okay, so which is the correct answer? You can see option A is the correct answer here. Okay, fine. Coming to next question, find the product of the given reaction. Again, this is addition of ammonia and its derivative. So this is very simple. What we have to do, just remember, you have to remove water molecule, right? So here it is C, I'll write like this, C double bond O, CH3, and then we have H2N, okay, NH2CH2CH3. So here if you remember, one water molecule is removed and we will have this one CH3 double bond N CH2CH3. Okay, so I'll get CH3 double bond N CH2OH is here, no, CH2CH3. So correct answer for this question will be option number B. Okay, next question number 4. To differentiate between pentane 2-ONE and pentane 3-ONE, a test is carried out. Which of the following is correct? So silver mirror test, iodoform test. So silver, see, both are ketone group. So I told you silver mirror test is the same as Tollens reagent, and ketones do not give that test. So both pentane 2-ONE will give silver mirror test, that is wrong. None of this we'll see. Now coming to iodoform test. For iodoform test, what is the group required? CH3CO. So if you see pentane 2-ONE, this is pentane 2-ONE, right? And this is pentane 3-ONE. CO, CH2 and CH3. So for iodoform test, I need methyl ketone group, that is this one, right? So pentane 2-ONE will give you iodoform test and it will give you a yellow precipitate. So pentane 2-ONE will give iodoform test. Option number B is the correct answer here. Okay. Next, the reagent with which both the aldehydes and the acetones readily react. So that means the reagent with which both aldehydes and ketones will react. So if you know Tollens reagent, Fehling solution is only for aldehydes, Skiff's is also not there, Grignard reagent, both will react. So correct answer is option number D, nucleophilic addition reaction. Okay, next, Fehling solution is not reduced by. Okay, so as I told you, Fehling solution will not react with aromatic aldehydes, right? So correct answer for this question is option number C, benzaldehyde. Next, Clemmensen reduction of a ketone is carried out in presence of which of the following? So what is the reagent for Clemmensen reduction? ZnHg and HCl. Correct answer is option number B. Okay, so these all are PYQ students. I'm telling again and again, see how easy questions have been asked. So please do not forget to complete this chapter. Okay, next, the order of reactivity of phenyl magnesium bromide with the following compounds. Yes, here something that we have to tell. Note, okay, reactivity of aldehydes is more than ketones. Okay, and nucleophilic addition reactions is proportional to steric hindrance. Okay, less is the steric hindrance, more will be the nucleophilic addition reaction. Less steric hindrance, more will be the rate of the nucleophilic addition reaction. Clear? Less steric hindrance, more reaction. Okay, so now if you see, aldehydes and ketones will be more. So these two are ketones, so definitely one will be highest. So you can see there are two options where one is highest, so we can eliminate A and B. Now if you see CH3 group is there, PH group is there. These are bigger groups, right? Benzene rings are there, more steric hindrance, less reaction here. Here less steric hindrance, more reaction. So after 1 there will be 2, then 3. So correct answer will be option number D here. Okay. Next, a ketone gives a yellow precipitate when treated with I2 in alkaline solution. The ketone is. So yellow precipitate, I told you methyl ketones, okay, iodoform reaction, methyl ketone should be there. So correct answer is option number B here. Okay. Next, a reaction between a carbonyl compound and a Grignard reagent is termed as. So just now we discussed Grignard reagent addition is a nucleophilic addition reaction. So correct answer is option number A here. Okay. Next, ethanol is treated with a primary alcohol in presence of HCl gas. The reaction is, okay, ethanol. So there is a reaction of aldehyde with alcohol. And if you remember, addition of alcohols we have studied, it gives you acetal and then, sorry, hemiacetal and then acetal. So this reaction is nothing but acetal formation, right? Okay. Next, here one question is there. So this question is again from your previous year question. Grignard reagent, you can see there are two reagents with dilute NaOH, right? So definitely this is your aldol condensation, and here you can see there is no alpha hydrogen. So that means this one will attack on this one. So how we can draw? So we'll draw first like this, COH, okay, and then I have here CH3 COH, right? So this carbon can attack, this is the alpha carbon, this will attack here. Here there will be one H and this one will become OH. So first product what I will get is benzene ring is there, okay. To the benzene ring I have one carbon with OH. Next I have CH2, okay. Then we have CHO. So then there will be dehydration here and I will get a double bond here. So I have benzene, then CH, then I have to have a CHO group. So I think this is the product that is asked here. So correct answer is option number B. Okay. Next, so this is a question, a homework question for you. So these are all PYQs. So you have this one. What is the reagent required to get into converted to this one? Okay. So please answer this question. Okay. And do not forget to comment down the answer. Okay, so students, we have completed one major part of this chapter, that is aldehydes, ketones and carboxylic acid, that is your chemical reactions. So now it's time to revise once again. Okay, so under chemical reactions I'll just tell randomly, you have to think in your mind. Okay, so chemical reactions first we studied is nucleophilic addition reaction. Under that we have addition of 5 things: addition of HCN, addition of NaHSO3, addition of Grignard reagent, addition of alcohols, addition of ammonia and its derivatives. Under ammonia and its derivatives we had 7 categories. Okay, first one. Next it is reduction. Under reduction we have reductions to alcohols. Reagents required for here is NaBH4, LiAlH4 and H2 palladium. Then we have reductions to hydrocarbons. Under that we have 2 reactions, Clemmensen and Wolff-Kishner reduction. For Clemmensen reduction, what is the reagent? HCl and Zn and HCl, and for Wolff-Kishner we have NH2KOH, ethylene glycol. Next we have oxidation reaction. Under oxidation 3 reactions, we have Tollens test, reagent is Ag, silver mirror test, Felling solution, copper oxide, red color precipitate, and oxidation of methyl ketones. Here it is iodoform reaction, yellow precipitate is produced. So 3 reactions over. The fourth one is your reactions with alpha hydrogen. Here we have cross aldol reaction and aldol reaction. Fifth one, reaction, other reactions categories there. Here we have Cannizzaro reaction, reagent required is concentrated NaOH, and then electrophilic substitution reaction. So here you have to remember that the aldehyde groups are your meta directing groups. So the electrophile will be attached at the meta position. Clear? So now you see how fast we have quickly revised it. So like this, you just need to revise when you are doing, when you are studying, when you are walking. So just keep revising the reactions. Okay. So yes, this is very important. Now please, if you are enjoying this series, if you are thinking that this series is helpful in your KCET preparation, subscribe the channel and please join the WhatsApp channel. Okay. Link of the WhatsApp channel will be there in the description section, and please comment down the homework question, and if you have any doubt in any of these concepts, do not forget to comment down. I'll definitely address it. Okay. Thank you for watching and see you soon in the next episode where we are going to start carboxylic acids.